This video is on section 4.1, which is titled Quadratic Functions and Transformations. And the learning target that we're going to go over today is to identify and graph quadratic functions. So the main thing is just going to be looking at what a parent function is and applying the exact same transformations we did in chapters 2 and 3. And we are moving back to the Algebra 2 textbook. So the parent function of every quadratic function is y equals x squared. That's going to start at the point 0, 0 and point upwards in a parabolic direction. So the definition of a quadratic function is a graph in the shape of a parabola, which is this U formation that's right here. And the equation has the highest degree, or its largest exponent is 2. So you may have some other terms in there, but the highest exponent you see will be 2. You won't have any 3s or any 4s, anything higher than that. That's the biggest one you'll see. And the one way you could write a quadratic equation is in vertex form. And vertex form is not as easy to graph in a calculator, but it's a lot easier to graph by hand, and it tells you a lot more information about the graph and the equation than you would in any other form. So vertex form is y equals a times the quantity x minus h squared plus k. Now again, we've seen this h and k letters before, where they're responsible for horizontal translations and vertical translations. Any numbers that are added or subtracted on the inside is a horizontal translation, and any numbers added or subtracted on the outside is a vertical translation. And for horizontal, it's always the opposite sign you see. So since this is minus, we're going to be moving our graph to the right. And then this a number out front is responsible for any stretching or compressing. And then, of course, reflection is a negative out in front. So these are transformations we've gone over multiple times in the past before, but we're just going to keep reviewing them. They're not going to go away, and they'll be in this class for the rest of the semester. Now, one very important useful thing in vertex form is that you can actually see and label what the vertex of the equation is. Now, a vertex of every quadratic function is either the minimum or the maximum point, depending on which direction the parabola is pointed. So since this example right here, y equals x squared, is pointed up, it doesn't have a maximum because it keeps going on to infinity on both ends. It does, however, have a minimum, and this minimum point is called the vertex. So it is a min or max point. Now when you were looking at it in vertex form, a times quantity x minus h squared plus k, the quantities in there can tell you what the vertex is. And in fact, the vertex is the point hk. So since this parent function is y equals x squared, there is no h and there is no k, so that is the point 0, 0. That is the vertex of every single equation in vertex form. If you would shift it to the right, then it would be a positive value. If you shifted it to the right 2, it'd be 2, 0. And then if you shifted it up, it'd be 2, 2, 1 or 2, 2, or however many units you shifted it up. Now the axis of symmetry is the vertical line that divides the quadratic in half so that it's being reflected across each time, so that it's even on both sides of the quadratic, and that's why it's called the axis of symmetry, because if something's symmetric, that means you have identical things on opposite side of that line. So it's the vertical line that cuts the quadratic in half. And then I'm going to be a bit more specific that the axis of symmetry will always go through the vertex of every quadratic function. Okay, and if you have your equation written into vertex form, your axis of symmetry will always be the equation x equals h every single time. So our vertex is point hk, and our axis of symmetry is the line x equals h. The vertex is always a point, and the axis of symmetry is always a line. Don't get those two mixed up because they're not the same thing. So in class, we're going to be talking a bit more about transformations and specifically translations and how that affects the graph written in vertex form. And then the next time we'll be talking about a different form to write your quadratics in, which is standard form. So this is vertex. Make sure you have this formula written down in your notes and that you understand H and K are responsible for the translations and what vertex and axis of symmetry are. All right? Thank you.